Hello, everyone, and welcome to today's webinar, Integration of Biopesticides into IPM Systems, presented by BioWorks. I'm Robin Sitberg of Meister Media Worldwide, and I'll be moderating the webinar today. This webinar has been approved for a half CEU credit in Integrated Pest Management from CCA. So it's important to remember that at some point during this webinar, an attendance poll will be sent, and you must respond to receive credit. Once you respond, or if you respond, when the webinar is finished, you'll receive an email with the QR code for reporting your credit. You simply scan the QR code and submit it. It's really important to know not to close your browser before the event is fully ended, or you will not receive the email with the QR code. This is also for the viewers watching the archived webinar. We will have some time for questions at the end of the webinar, so if at any time during the presentation you'd like to ask a question, just go ahead and type it in the question pane at the lower left corner of your screen and click submit. You can do this at any time during the webinar and we'll answer questions at the end. Before we begin, I'd like to introduce today's speakers. Dr. Michael Brownbridge is a Senior Technical Services Manager with BioWorks. He provides technical support for the company's catalog of disease and pest management solutions and their application in integrated plant health management programs. Prior to joining BioWorks in 2019, he was fortunate enough to have traveled the world applying his craft with research and outreach positions in Israel, Kenya, the US, New Zealand, and Canada, putting new biological tools and knowledge into the hands of growers. Our second speaker, well, actually our first speaker, second to be introduced, is Julie Graesch, and she is Technical Services Manager for Insect Management for BioWorks. She has 16 years of experience as a biological scientist and entomologist. She's practiced in laboratory, greenhouse, and in-field research, as well as biological technical service support for the IPM industry. She's been with BioWorks for 5.5 years as Technical Services Manager, and she's previously held positions at BASF, Becker Underwood, and Iowa State University. She has a master's degree in agriculture with a focus on entomology from Iowa State University. So now I'm pleased to turn the program over to Julie Graesch.
Excellent. Thank you very much. And I also want to thank you for the introduction. Thank you for hosting the webinar, and thank you all for being here. So Michael and I are going to be talking about integration of biopesticides into IPM systems. I'm going to start by talking about biopesticide basics and compatibility, and then I'll hand it off to Michael to talk about programs. So biopesticides are pest management agents derived from natural sources such as fungus, bacteria, viruses, plants, animals, and minerals. If you break down these active ingredients, you can put them into two basic groups, biochemical and microbial. We will be talking more about that in the slides to come, but we're introducing them here. Biopesticides are regulated with the Environmental Protection Agency as plant protection products, and they are registered in each state as pest and disease control agents. Biopesticides are fantastic tools in integrated pest management, but it's important to know where they work and where they don't. Biopesticides should avoid being used as curative, although there are some products that are good knockdown products. They should also not be used as a standalone, but part of an integrated plant health management program. They should be used preventatively, starting as early as propagation, and they can be used through finished production. So what I'd like to do now is I have a couple of slides where we're going to talk about the bioinsecticides and the biofungicides, the various products that are available, and the active ingredient and mode of actions that are offered in these products. So starting off with bioinsecticides, and this is going to be for both foliar and soil-borne arthropod management. With the microbial products, we have active ingredients that include fungus, bacteria, and nematodes. Active ingredients in the fungal products are Bavaria, cordyceps, and metarhizium. And then we in the bullets, you can also see a number of products that are available. Most people are familiar with BT, and there are also a number of nematode-based products, Steinernema and Heterorhabditis. On the biochemical side of things, we have products that are botanically based, and these include active ingredients like azadirachtin, pyrethrins, and essential oils. There are a number of toxins that include spinosad, ivermectin, and spider venom. And then there is a large category of others. And this is typically where you would find the insecticidal soaps and the horticultural mineral oils. Depending on the active ingredient in the end-use formulation, you will have one or more mode of actions that will be working on the pest populations, such as suffocation, desiccation, parasitism, and so on. Now, on the biofungicide side, starting by just talking about the foliar diseases, and then we'll also talk about the soil-borne diseases. On the microbial side, we have a number of bacteria and fungus-based products, and they can be broken down into two mode of action groups. Some products are going to work via antagonism. So these microbes are going to be creating metabolites that is going to disrupt cell membranes and inhibit fungal and bacterial growth. The other mode of action group are those that are going to work through competitive exclusion. And these microbes are going to compete with the pathogens for both space and nutrients. On the biochemical side, we have products that contain potassium bicarbonate, which offers a physical mode of action that will desiccate fungal and bacteria spores and mycelia. There are mode of action products that will inhibit formation of chitin. And finally, there are both botanical and microbial products that will have an induced resistance response or an activation of the plant's defenses. Now, for the biofungicides for root health, a very similar process here. So we have a number of active ingredients, both fungus and bacteria, and trichoderma, bacillus, streptomyces, and pseudomonas. And here again, these products are going to have one or more mode of actions that are going to be working on these pest populations. Those mode of actions include competitive exclusion, antagonism, induced resistance, and parasitism. So why would you want to integrate the biopesticides into your IPM program? If you're using basically a synthetic program and you're incorporating the biopesticides can be excellent tank mix and rotational partners. They're also excellent resistance management tools because, as we just learned from the previous slides, they are mainly physical modes of action. And if you have a population of resistant pests, these physical mode of actions can revert the population back to a more natural state and extend the life of your chemistries and have the chemistries work for you for a longer period of time. Biopesticides can also offer reduced application costs, such as shorter REIs, PHIs, and so on. Now, if you're also using natural enemies in your program, which include predators and parasitoids, you can start by using the biopesticides as dip applications. And this is going to knock down pests on any incoming plant material. Biopesticides are also fantastic as spot treatments. Natural enemies typically don't work under really high pest population situations. And so we can really use these biopesticides advantageously to drop populations and help the natural enemies work better. Finally, the timing of the biopesticides and the natural enemy releases is important. You want to make sure you do your sprays and then release your natural enemies and not the other way around. what we want to get across to everyone is that integrated pest management does not mean no use of chemical insecticides or fungicides. It's intelligent timing and use of these pesticides to control these pest populations with our other IPM tools. And of course, compatibility is going to be important, which is why we're going to spend more time on it. So here's an example of some chemistries that can be used for management of a specific pest population, and in this case, whitefly. So MOA stands for mode of action, and we have a number of IRAC mode of action groups and products that can be used against whitefly. However, what you'll see here is that many of those have a parentheses statement behind them saying that they will not control the Q biotype, which is a species of whitefly that has become resistant to many, many chemistries. And this is where the biopesticides can come in for resistance management as a resistance management tool. So the biopesticides are going to be in the mode of action group UN, which stands for unknown. And again, because these are physical modes of action, we're taking out some of the resistant insects and reverting them back to a more natural state where our pesticides will work better. Of course, we need to also understand how all three of these components, our natural enemies, our chemicals, and our bioinsecticides are going to work together. And so we're going to spend a few minutes now talking about compatibility, specifically pH, physical, microbial, and natural enemy compatibility. Starting with physical compatibility. Most people are familiar with the jar test, and doing these jar tests will pretty quickly show you if a tank mix is going to be compatible or not. Incompatible tank mixes will have separation, precipitation, sometimes heat generation, and so that's a clear sign of incompatibility. However, on the compatible side, you'll have a nicely mixed solution. However, it's important to note that a jar test will only reveal physical incompatibility. It does not show other forms of antagonism, such as pH and microbial. Starting with pH, is pH an important factor in compatibility? It absolutely is. And you can find this information in the label. So in this example, we have two products. We have Millstop SP, which is a potassium bicarbonate, and it has a pH of 8+. The second product we have is EcoSwing. This is a botanical biofungicide, and it has a pH between 5 and 6. So if we now look to the labels, the Millstop label will tell you to do not adjust spray solutions after mixing of product. So we want that spray solution to remain high pH. However, on the EcoSwing, the label will tell you to not adjust the spray solution higher than 8. So by reading the label, we can very quickly and obviously see that these products will not be compatible when tank mixed. So this is just a plug to make sure that you read the label. On the biological compatibility side, this is tests that will need to be done in the laboratory. For a compatible test, we have an organism, Eulicladium udamancii, product Battery-Stop. This is a fungal biofungicide, and it was tank mixed with the chemical fungicide Gattin at both the low and the high rate. And we can see with that tank mix that it did not change the number of colonies or the size of those colonies, so we would consider this a compatible tank mix. On the incompatible side, we see the same organism tank mixed with Pageant intrinsic fungicide, and we see no fungal growth. So this is a very obvious sign that the chemical killed the biological and that they're not compatible as a tank mix. So where would you find that information? So you can go to the distributors. You can also go to manufacturing reps, technical people, or to the to the manufacturing websites. Oftentimes, you can find the information free and available to you on the website. Since we were just talking about Batre Stop and Pageant, here is an example where it's showing you that that was not compatible. And also another a note is that if there are comments associated with these compatibility assays, sometimes it's really important to take note of that because it will tell you sometimes your application interval. Finally, the last thing that I'm going to talk about is natural enemy compatibility. So there are also a number of resources available to you. Some of them are paid for, some of them are free to you. Again, if you go to the insectary websites, you'll typically find either information on the line or also as apps. So fortunately for us, all of these various websites are using the same 1 to 4 toxicity rating scale. And it's also a stoplight system where it is color-coded, so it's very easy to see. So with your greens, these are going to be non-toxic with short to no residues. Your yellows and oranges are going to be slightly to moderately toxic to your natural enemies, but still excellent IPM tools. And finally, we have our reds or 4s. These are going to be toxic with potentially longer persistence. However, there are some exceptions to the rule, and we will be talking about that as we go through some examples. So let's say in your operation, you have a Western flower thrips population that you want to set up a program. So we gather all of the biopesticides, the natural enemies, and the chemistries that are available to us to manage this pest. Our first line of defense is using the biologicals, starting with the dip as mentioned, and also doing the biopesticide sprays. And as we discussed, there are both biochemical and microbial options. Using natural enemies for Western flower thrips, there are both foliar and soil-based natural enemies that can be used for management of this pest. And finally, there are also the second line of defense, the chemistries that can be used. The color coding here is intentional, and as you go through your chemical cabinet, we will need to find out what is going to be compatible with the natural enemies and what won't. It's also important to note that most growers are not looking at the fungicides, and just because it is a fungicide doesn't mean that it's not going to kill a natural enemy. So what I'm going to do now is we're going to go through examples of biofungicide, insecticide, and fungicide compatibility and what you might see if you were to look up this information yourself. Starting with the bioinsecticides. So to orient yourself here, we have a list of natural enemies that are in green, and at the very top we have the various products that we want to use. So in the blue box, we have 2 different products. We have a horticultural mineral oil and a insecticidal soap. And if you look just at the color, you'll see that it's mainly red, orange, and yellow. So it looks like this is not going to be very compatible. And these are contact desiccation and suffocation agents. So yes, it is going to have an impact on your natural enemies. However, if we look at the persistence, and persistence is a very important and key thing to look at within these charts, we see that there is no persistence. So as soon as the soaps and the oils are dry on the plant, it's no longer going to impact the natural enemy communities. So even though this looks like they're not compatible, these are still excellent tools to use in natural enemy programs, especially as spot sprays. The second product that I wanted to mention is spinosad, which is a toxin. And this shows you that the type of application can make a difference. So SP, which is spray, Spinosad is very detrimental to many of the natural enemies. However, as a drench, as long as you're not contacting a lot of the foliage, it is more compatible with the natural enemies. On the insecticide side, and if you remember back a few slides to the color coding we had on some of the insecticide products, we have Avid and Hachi Hachi, which are two products that can be used for thrips management. And if we are just looking at the color, we see lots of red, orange, and yellow. So pretty quickly we can see that these products are probably not good to use if you're also using natural enemies. However, Mainspring and Overture are generally green with just a little bit of yellow. So if you had the choice in your chemical storage of these four and you're using natural enemies, you want to choose the ones that are more compatible. Now, I also wanted to mention there are going to be some products like Pedestal in this example where it's going to impact the natural enemy community across the board, but it's still a good rotational program if you're using the chemistries to have in your back pocket if you need to use it. Persistence, again, is an important thing to look at, and if we look back at the Avid and Hachi Hachi example, these are going to continue to impact the natural enemies for at least 1 to 2 weeks after application. So another indication that these chemistries are going to have longer lasting impacts on natural enemies. So finally, before I pass it back to Michael, we have the fungicide applications. And again, fungicides doesn't mean that it's not going to impact an insect community. So if we look at Affirm and Cleary's, these are going to be more detrimental on your natural enemies, red, orange, and yellows. However, the other products, Daconil, Heritage, and Manzate, are mainly green. If you're using several natural enemies, some of these products are going to be more detrimental on specific species. So these can also be judgment calls on depending on what natural enemies you're using in your program. Finally, we have sanitation products. If you're using microbials like the beneficial nematodes, entomopathogenic fungus, Bavaria, Metarhizium, Eiseria, you don't want to tank mix with the sanitation products. Those are biocides, and so they will, of course, kill those organisms in the tank mix. With that, I'm going to now pass it off to Michael to talk about programs.
Great stuff. Thank you, Julie. What a wonderful introduction. So what Julie's done, I think, a great job of it is giving you the background around the what, the whys, and the hows of integrating biologicals, biopesticides into IPM systems. And I'm going to change things up, as Julie said earlier, so we can take a little bit of a deeper dive into some of the tank mix combinations and the benefits that they can actually deliver. I'm going to start off right here. One of the reasons for considering a tank mix is to actually improve the efficacy of a bioinsecticide spray. And if you consider a crop where you may be using a fungal-based product based on Bavaria bassiana, for example, to control thrips, that's great. These work really, really well against thrips. But what if you also have aphids and spider mites? We know that very few Bavaria strains actually kill spider mites, especially the wettable powder formulations, and they work but slowly against aphids. How can we improve the effectiveness of a biological spray? It's actually relatively straightforward if you think about it, and that we do have options in terms of tank mixing with products based on azedoractin, mineral, or botanical oils. Then that tank mix combination of fungus and other will actually control all three pests. So the beauty of that is you're making one spray, but you can control all three pest species concurrently. So We know that tank mixing can also improve efficacy. And again, starting off with the fungal products, fungi like Bavaria, Metrorhizium, they infect insects through the cuticle, through their body walls, whereas a product like azedoractin interferes with the insect molting process. Now, if we think about pests like whiteflies, or perhaps even better, an example, aphids, they move very rapidly from one life stage to the next. And when they molt, when they shed their skins, they can also shed spores of the insect pathogen if it was applied shortly before that molting event took place. And when they do that, they basically escape infection. So by slowing down the insect development process, we're slowing down the molting process as well. So using a Bavaria product with azedoractin effectively provides a wider window of opportunity for the fungus to successfully infect and kill the insect. And this is a really nice piece of work, an example which illustrates this really well, I think, that shows that a tank mix of Bavaria and azedoractin not only improved the speed of kill, but also the level of kill of Burmese whitefly. So a simple tank mix gives you benefits in terms of improved program efficacy. Second example, similar in many respects, it provides an example of tank mix benefits, again, using Bavaria bassiana, this time targeting green peach aphid. Aphids, and any of you have ever had green peach aphid in particular, they seem to sort of go from wee little babies to adults overnight, crazy fast. So how can we actually really kill a lot of aphids by using the two biopesticides together? And these are data from a trial that was done where Bavaria bassiana product was tank mixed with EpiShield, which is derived, it's just a combination of two essential oils. It's a 25B product. We actually got really good control of aphids with that combination, and it was significantly better aphid control using that combination than actually was achieved using either product individually. So microbials, sorry about that, forgot about that piece. Microbials are also really good partners with natural enemies. And in this example again, a Met 52 EC spray, it's now called Laugard M52, an oil-based formulation of the Metrorhizium fungus, was part of an integrated program for targeting thrips and spider mites. And that integrated program also included the release of Cucumeris predatory mites via mini sachets, hanging those mini sachets in the crop. Now, the combination provided really good control of thrips on chrysanthemums, and by 8 weeks you can see that the combination, the Metrorhizium Cucumeris combination, gave the best control, and it outperformed the insecticide treatment, which in this case was success. But it also provided really good control of two-spotted spider mite. So two very, very different pests, but you can achieve control. Again, you can do this by strategic selection and use of a thoughtful, let's say, or an intelligent, using Julie's phrase here, an intelligent tank mix partnership. What about biofungicides? Can we use biofungicides with other crop protection inputs? And I took this information, it's just a tiny piece out of the BioWorks compatibility database for Root Shield Plus. And it shows actually how Root Shield Plus can be successfully used as a tank mix or in rotation with many conventional products. What I think is also important to note here is that Root Shield Plus is also compatible with several natural enemies that may be being used to combat soil-dwelling pests or pests that have a soil-dwelling stage in their life cycle, thrips specifically in this case, or it could be fungus gnats. So using a biofungicide in place of a chemical fungicide, and cast your mind back to what Julie was saying, you have to think about the whole program. There's a lot of chemistries will actually kill the natural enemies. So by utilizing a fungicide in this case, we can escape that incompatibility between chemistry and some natural enemies. Now, this graph, it's kind of thrown in there just to show you what I said is actually true, I guess. And it sounds counterintuitive that you can actually tank mix a fungus with a fungicide. But these data show how root colonization by Trichoderma hartzianum T22, that's one of the actives in Root Shield Plus, was actually unaffected when it was applied together with various chemical fungicides, including Cleary's 3336, Subdue Max, or a combination of Cleary's and Subdue Max. And it really shows, and Medallion too, and it really shows that you can use biofungicides very successfully with synthetic chemistry, and that you can use biological materials for resistance management programs in both organic and conventional production systems. And I think that's an important thing. And in conversations, you know, sometimes you have to use biologicals in organic programs. No, you're not. Most of our biological products are actually used in conventional systems. About 70% of biological products are used in conventional production systems. So it's not an either or. You can use them in organic systems. You can use them in conventional systems as well. You just have to make sure you choose the right materials to use together. So to illustrate the point further, this is a nice example, I think, where the polyoxin D zinc salt product also, and remember that's a fungicide which inhibits chitin formation by fungal pathogens like powdery mildew, and the Bacillus biofungicide double nickel in this case, they were inserted into programs with chemistry, and these programs contained Quintec, Coside, and Procure, which were being applied for powdery mildew control on pumpkins. Now, if we look at the data, where in all of these cases, there's no efficacy penalty to using either of those biofungicides in a rotation with those products. And if you compare the program results where the biologicals were used, and in this case is where chemistry alone was used, again, but using different products in rotation. But it shows you no efficacy penalty to using either biofungicide in rotation with those products. That's the sort of combination that concurrently supports resistance management and pesticide reduction goals. And similarly in strawberries, when the botrytis management product Botrystop, based on Uocladium udimanzii, it was applied alone at the 3 or 4 pound rate per acre, it significantly reduced the incidence of botrytis on berries compared to the untreated control. Now, if we had the standard rotation, chemical rotation is a mix of switch together with Captan. So what we did, we still included the switch Captan rotation, but we inserted the biological Botrystop. We took out Captan, and every time Captan was going to be used, Botrystop was used in its place. So if we shift over to this graph, the chemical only, the standard, the grower standard, the switch Captan is the red bar there. The green bar shows the switch Botrystop. So we actually achieved slightly better control, although not statistically better, but numerically slightly better, using the biological chemical rotation rather than the chemistry alone. So again, by still including switch in the program, it enhanced efficacy of the program now against both botrytis and Neopestalotiopsis. But again, we achieved that goal of reducing the number of chemical sprays, which again supports sustainability and resistance management goals. Now, biofungicides, microbial biofungicides, are also compatible with some synthetic insecticides, particularly systemics. So by tank mixing trichoderma-based products, which are applied by drenching, together with systemic products like Contos or Mainspring, you can kill 2 birds with 1 stone and save labor by making 1 drench application versus 2, controlling root diseases and pests at the same time. So again, labor saving Labor's kind of important and kind of expensive in any production system these days. So here's a way to save labor, but also to achieve better levels of control overall. One of the questions I'm often asked is whether soil-applied microbial fungicides are compatible with other biological inputs, like mycorrhizae. And mycorrhizae are often applied to woody ornamentals to basically enhance their access to water and nutrients from the soil. And yes, they can be safely used together with microbial biofungicides based on trichoderma and bacillus. And there's quite a lot of evidence in the published literature to actually show that use of the two materials together, they actually complement each other when co-applied to the soil. And you get the additional benefits of promoting root development, plant health, and plant resilience. So what about tank mixing biofungicides for soil-borne diseases? When we do lab tests on using media plates, and we sort of plate Bacillus subtilis, which is the active used in Cease, Rhapsody, Serenade, that can actually inhibit the growth of trichoderma. But what actually happens in the soil? And to test this, we applied Bacillus subtilis and Root Shield Plus to lettuce seedlings, and then monitored root colonization after the fact. And there were three different application regimes tested. In the first one, Cease was applied 24 hours before Root Shield Plus. The second one, it was Cease and Root Shield Plus were actually tank mixed and co-applied. Then in the third one, Cease was applied 24 hours after Root Shield Plus. And then the root colonization by trichoderma was determined 5, 10, and 15 days later. Now, looking at the graph there to the right of the slide, you can see there's a little variation in the numbers, but these data are inherently variable. If you don't look at the actual numerical values, but the trends, you actually see that colonization levels in each treatment don't really change over time, and there's not a whole lot of difference across all of those root colonization levels. The bottom line, yes, you can use Root Shield Plus or a trichoderma product. This is specifically to Root Shield Plus, together with Bacillus subtilis, so you can co-apply or apply together in rotation. So assuming those products are compatible, which combinations make sense? And if you consider two bacillus-based biofungicides, Triathlon and Cease, both good products in their own right, but efficacy against certain diseases can actually be enhanced by tank mixing with other materials, such as a potassium bicarbonate product like Millstop, which has a physical mode of action, or an elicitor like Regalia, which works systemically to promote plants' own defense mechanisms. In addition, we typically see activity enhanced against a broader range of diseases by using such tank mixes. Now, unlike chemistry, many biofungicides deliver other plant benefits. They can help plants cope with and recover from abiotic stress events. And you think, what's an abiotic stress event? Heat, drought, even cold. They can stimulate root growth and development and proliferation of root hairs along those developing roots. And they can, by doing that, they essentially enhance a plant's access to water and nutrients, which in itself will help grow a healthier and stronger plant. Several of these microbes also actually solubilize macro and micronutrients in the soil and make them more biologically available to plants. And this is one of the wild things I think about what microbes can do to plants. They actually help the plants assimilate them within these elements within the plant itself. And all this in addition to their ability to protect the plants against soil-borne diseases. So biofungicides, biopesticides, they're versatile, multifunctional crop protection products, and really excellent additions to an IPM program. They have proven efficacy, bring unique modes of action into a program, which is essential for resistance management, and they can enhance plant growth performance. They're short REIs, mean they can be applied with minimal disruption to day-to-day crop management activities. And their use really helps address some of the biggest challenges facing production horticulture today in a very, very cost-effective way. So I hope you've learned something today, something to take home. I'm sure there's a ton of questions, and Julie and I are here to hopefully be able to answer them. So Robin, you're moderating this section. Please take it away.
Yes. Yes, there are a lot of questions. We have a large audience today, so we're already getting a lot of questions, and we do have, looks like about 20 minutes, so we can get to a lot of them. So keep sending them in if you have one. The first one I'm going to ask is about copper. And it says, I know that copper is hard on BCAs. We have a new product from BioAg that we will be using, and it has 0.08% or 0.08% copper in it. Is that enough to damage my BCAs? And that's number 10 if you want to look at it.
Yeah. Copper is pretty harsh against a lot of things. Copper will affect biofungicides and some biofungicides and bioinsecticides. I'm less familiar with effects of copper products on BCAs. Julie, you might be able to tack that one better. I'll just stick to the microbial side for now. If you're using a copper product for a living organism, a microbial that has to germinate and grow, be it an insect-killing fungus or a trichoderma type fungus, they have to germinate, and copper can suppress. It's very antagonistic to these organisms, or it may kill these organisms. So you've got to be very careful, particularly for soil-borne diseases. Now, on the foliage, you can actually tank mix copper with bacillus products, and they do work well together. And that's really down to when applying a bacillus product, and I'm thinking probably streptomyces as well. The activity against foliar diseases does not rely on germination of the spores in those products. Most of the activity against foliar diseases comes from the metabolites that these bacteria produce during fermentation that are included in the formulation. So you can tank mix with copper. Copper does not affect the activity of those metabolites. But do you want to take a stab at the BCAs, Julie, with copper?
Yeah, on the backside here, I was looking up information about copper, and I think it's going to depend on the natural enemy. Some of them are going to be more compatible. Some of them are going to be less compatible. Just looking up Californicus was one that I looked up, and it does seem to be compatible with copper. So I would recommend either looking up the compatibility of the various copper agents, or also reaching out to somebody and having them help you, whoever you're getting your natural enemies from, reach out to them. Sometimes if there is not any information out there on the products, you can also ask the manufacturers and or insectaries to conduct some of these tests for you so that you have that information. But generally speaking, you're going to have to look at each individual natural enemy and that you're using and how it is going to interact with copper or whatever other chemistries that you're using in your program.
Okay, that sounds like a pretty thorough answer to that question. Several people are asking how they can obtain the compatibility charts. So maybe you can provide that link.
Yeah, just as a general comment to that, pretty well all of these, from BioWorks perspective, the compatibility charts are available for all the products in our portfolio. They're available, their compatibility data sets are available through our websites. And if you click on a particular product, there will be one of the options you have on this page you land on is typically there's a little box that says compatibility. If you click on that, you have two options. There's a compatibility tool that we have on site, which saves you sort of looking through the whole data set, where you put in the BioWorks product and then the name of the chemical product of interest, click on that. And if we have compatibility data on those, it will come up and it'll give you some information. And the data we have gives you information on physical and biological compatibility. And if they're not compatible, it usually provides a little bit of a sort of a direction as to, say, maybe he's wait 24 hours between applications or 48 hours, whatever it is, between applications. Most of the products, the biological products certainly, will either have, they pretty well all carry some information on the label. Typically that's the do not mix with ever, ever, ever type of information, but also they will have, it'll give you the web address, go on this site for information. Some of the biological products actually have maybe a QR code. You just put that in your phone and it'll take you all the way to the online compatibility database. For the BCAs, they're available. The compatibility data sets are available on the manufacturer's website, so or as apps that you can download onto your phone. BioBest, Coppet, does Beneficial Insectary do one, Julie? I think they probably do. I think BioBee does one. I'm not 100% sure. But if you're using a lot of natural enemies, those are probably the sites to go to for compatibility data, as Julie demonstrated in the presentation.
Okay, our next question here, and this is a good one. I haven't thought about this, but when using biologicals, can we claim that we are pesticide free? We want to.
It's
so
a
they're not
loaded
using any
question.
conventional pesticides, I guess.
You could
So
say go ahead, Julie.
I was just going to say that the registered biopesticides are EPA registered, so they are considered pest control materials. If you're using biological, biopesticides, you can have a message around being environmentally friendly, using the biorationals and using natural enemies with that. And that's a fantastic message to provide to your end use plant purchasers, and letting them know what you're doing is a good marketing strategy. So biopesticide free, or I would say pesticide free, maybe not, but you are being environmentally friendly and so on and so forth. So there are ways to state that in a way that would be advantageous to you and for the purchaser.
And I've seen some signs in businesses that says plants grown without use of chemical pesticides, and you've got to be very specific about how you do it. But it's a gray area because we do have biological pesticides, biopesticides, which are biochemical. So potassium bicarbonate, that's a gray area. It's a very safe product, but so I think you've got to be careful in how you advertise this. I agree with Julie. I think there's ways around it without sort of breaking the law, because technically you are using a pesticide when you're using a biopesticide.
Okay. All right. We will move on to our next question, which is, do products that induce plant defense against pathogens such as regalia, lifeguard, etc., also protect against invertebrate pests?
Ooh,
I can answer that one. It is a great question.
Yeah. You go ahead, Michael.
I'm not sure about regalia and lifeguard. I can talk to trichoderma because, having done some research back in a former life, we did a lot of work on trichoderma effects, and yes, regalia and lifeguard are specifically sold as plant activators. That's what they do. Fungi like trichoderma and a lot of the other bacillus strains that are used in biofungicides also elicit plant defense responses. And plant defense responses are pretty unspecific. They're quite broad spectrum. They're kind of like stress responses. And the compounds that are produced can have, I'm not going to use the word insecticidal, but they can affect insect development speed. So they will slow down population growth. And this has been well documented, particularly for trichoderma. There's some really excellent publications out there on this. So instead of, say, you have a population of spider mites which doubles every 5 days, I'm making this up just as an example, it might take them 10 days for that population to double. And that slowing gives biological controls more time to basically consume more pests. So yes, they can have an effect on insect pest population growth. So there are some really wonderful, how should I say, side benefits, because it's not a pest management tool, but it can make other pest control agents work better. It gives them the opportunity to work better.
And just to add to that, if we consider the natural enemies, if you're turning on the plant's defenses, the plant could also be releasing volatile organic compounds either in the air or in the soil, and that can be attracting your natural enemies, either the ones that you're releasing or the naturally occurring ones. So in the soil, you could be attracting beneficial nematodes or, stratiolaelaps, Delocia, and then on the foliage, those volatile organic compounds will attract your flying insects, Aureus, ladybird beetles, and your parasitoid wasps, and so on. So by turning on those plant defenses, you can also get, as Michael said, other secondary responses, which I think is pretty cool in terms of attracting our natural enemies.
Mm-hmm.
Yep, absolutely. All right. Our next question is involving the droplet size and spray pressure. It's how to determine if the biological product through high pressure spray equipment, there's missing a couple words in there, I think, but they're asking about, is there a location to look up the information about the droplet size and the pressure, how to apply it through spray equipment? So some labels do not list this.
Yeah. I think if the label has a section on it, application through low volume equipment, it's typically low volume equipment that people are using, the LVM sprayers or the cold foggers, things like that, because there's a whole dilution piece which is different to sort of spraying per 100 gallons, because you're spraying per 10 liters, let's say, or 2.5 gallons thereabouts. So there's an adjustment oftentimes required to the rate used within that tank. If that information is on the label, then that piece of equipment can be used to apply the product. We do run, again, I speak for BioWorks, anything that can be spray applied, we tend to run through different pieces of spray equipment to make sure that the spores will survive the process. So I would say that it's generally speaking for products like Bavaria bassiana, for Bacillus, for Streptomyces, it's no problem putting it through any of those machines. Where I think there are still a little undecided, but I would err on the conservative side, is when we're using pulse fogs, the thermal foggers, for example. Even the biopulse fogs, they generate a lot of heat. It's how they atomize the liquid into tiny spray droplets. So they will have an effect on the viability, certainly, of fungal spores, bacillus spores. Bacillus is basically bulletproof. They'll go through those things just fine. But again, if you're applying it for a foliar product, the materials, it's not the spores so much we're concerned about, it's these lipopeptides, which are a little heat sensitive. But pressure, small droplets, no problem.
And
Okay.
just to add to that, we typically tell growers to apply to glisten. So you want to get that full coverage on the plant. And again, depending on what you're trying to do, if you just want it to get it on the foliage, you don't want to apply to runoff. If you do want to get some of the product to the soil, then you would want to apply to runoff. So applying a sprench. So it depends on what you're targeting. It depends on if it's in the soil and if it is on the foliage. And the other thing that I'll say to this is that the biggest reason for biopesticide failure is poor coverage.
Yeah.
A lot of the pests, arthropod pests, are going to be on the underside of the leaf. So if you're doing an overhead application with a boom sprayer, you're probably not getting the underside of the leaf, and you're not going to get that coverage. And a lot of the biopesticides are contact. So if you don't get on the underside of the leaf, you don't get control. So it's really important to think about your application equipment and ensuring that you're getting that good coverage so you are getting the most out of your biopesticides.
That's a great point, Julie, and it really speaks to how good is the applicator, how good is the equipment. Now, the nice thing about the low volume sprayers, the mist sprayers, those spray droplets typically will penetrate in a plant, in a leaf canopy, much better than a large spray droplet. So there are advantages, but there's a little bit of art, there's a little bit of science to spraying, and there's a lot of applicators that I would bet, and I hate to say it, that don't spray particularly well. I think they have to point the gun very close to the plant and soak it, and all that does is force the leaves down. And Julie's point, right on the money. You don't want the leaves facing down, particularly if you're targeting a pest, the majority of which are on the underside of the leaf. Basically, you want to have the end of a spray stream, if it's a handheld targeted device that you're using, at the end of that spray stream, you get a swirling action of the spray droplets themselves. And you can see the leaves moving around with that. That's what you want. That's giving you coverage on the underside of the leaf and on the top side of the leaf. The best resource I know of to go to for any information on good application techniques is on the DRAM website. They have some really good instructional videos and reading material directly on their website, and that would be my go-to place if you want to find more information on it. Just as an aside as well, there are many ways in which you can improve your spray technique, and one of the simplest is actually buying water sensitive or oil sensitive spray cards. And Julie and I were debating, should we include this information in the webinar or not? So here we are doing it anyway. But they're yellow cards, which if water hits it or an oil-based material hits it, it turns blue. And you can tell if these are put out into the crop before spraying, and don't have the applicator put them out into the crop, have somebody else, so the applicator does not know where these are, and then pull them out as soon as the spray is done, and you'll see how well, how good the coverage was inside that crop. And it's a really good learning tool, so you can understand, well, I did this here, I did this here. What is good practice, good application practice? So it's a great way to become better at being an applicator. And I'll just wrap up as well. Julie, spot on again. Spray coverage is one of the most important things. What's one of the things that affects spray coverage? Obviously, the applicator and the technique, but also, are you maintaining your spray equipment in good shape? And that means everything inside that piece, whatever piece of equipment you're using. And it goes all the way from, the motor's running well, the pumps are running well, the nozzle is not worn, everything like this. Everything is important to achieving good coverage. So it's a long answer to a short question. I'm sorry about that, but it's pretty important
question.
It's a very important question.
Yeah, well, it's great information. Obviously, much needed information, since we had questions about it. That wasn't the only one. So Well, we are out of time though, so I need to wrap up the webinar. As a reminder, an on-demand version of this webinar will be archived in the next couple of hours, and you can use it, you can access it at the same link you used to get on today. And you'll also get an email link tomorrow with a reminder that you can, rewatch parts of it or all of it. Remember not to close your browser before this event is fully ended, or you won't get the email with the QR code if you're looking for credit. And this is, again, also for the viewers watching the archived webinar. So if we didn't get to your question, I will forward them to Michael and Julie, and hopefully they can get back with you at some point to follow up with you, because all the questions were important. Like I said, we had a large audience today, so it was difficult to get to all of them. But thank you, everyone, for your time today, and especially thank you to Michael and Julie for the information, and to BioWorks for making the webinar possible. So thank you so much, and have a great day.
Thanks, Robin.
Yeah, thank you.